Hello, Integrated Math 1. Welcome to, I got this, Module 2, Topic 2, Lesson 3. And we're on the second day of this lesson. So we're going to be doing activities 3.3, 3.4, and our Talk the Talk today. We won't quite do all of it, but we are going to get through a pretty good chunk of it. So we, of course, have been talking about modeling linear inequalities. That's what this whole thing has been about. So we're going to practice a little bit more with that. Now, we were talking about Alan selling boxes of popcorn last time to save up money for his camping trip. Now, Alan has made it on the camping trip. Yay, Alan! But here's the thing. Alan's camping troop is now hiking. So Alan's camping troop hikes down from their campsite at an elevation of 4,800 feet, to the base of the mountain, which is at sea level. Just a reminder, sea level has an elevation of 0. So in case you weren't sure about that, they hike down at a rate of 20 feet per minute. That word rate feels important. I feel like it should be triggering something in your brain. So now that we have this information on page 128, they've even given you a graph. So you don't have to graph it. They gave you the graph. Yay. What I would like you to do first is I'd like you to write a function. And instead of calling it y equals or f of x equals, we're going to call it h of m. So we're hiking and m is going to be in minutes, right? So I'd like you to write a function h of m to show the troop's elevation as a function of time in minutes. And I'd like you to label the function on the graph, on the coordinate plane. So go ahead, take what we did yesterday about how we set up Alan's function yesterday. How would you set up Alan's hiking function today? Go ahead and hit pause, write down your function, and then hit play when you're ready to check your work. Okay, so I'm giving this some thought. First of all, I've got h of m. Let me pull out my pen here. There it is. So we've got h of m. Now remember how that word rate felt super important to me? Remember that rate of change was code for slope. That's right. That means my slope is 20. Oh, and they're hiking down. They're not hiking up. They're hiking down the mountain. So this tells me that my slope is probably going to be a negative. So my slope will be a negative 20. And that goes next to my independent variable, my m, because that's what slopes do. But of course, they didn't start at 0. Remember that our y-intercept is where we begin. It's where we start. They didn't start at 0. They started all the way up here at 4,800 feet. So I'm going to put negative 20m plus 4,800. Because that's where they began their hike, right? That's how this works. All right. Oh, and we're supposed to put it on the graph as well. So hang on. I'm going to erase this because then I'm going to draw the pretty version. There's the pretty one, all typed up, easy to read. And of course, I'm going to go ahead and label it on my graph. So off to the side on your graph in the margins over there, go ahead and label it. So I made it kind of smaller so it would fit on my graph, but I have now labeled my graph. This is h of m equals negative 20m plus 4,800. Ooh, and I may have accidentally already helped you a little bit with this one with number 2. I would like you to identify the independent and dependent quantities and their units. So what's the independent quantities units? What's the dependent quantities units? Go ahead and hit pause, jot it down, and then hit play when you're ready to check your work. Well, given the fact that the function was h of m, and also we know that the x-axis tends to be, you can totally use the graph, the x-axis tends to tell us what our independent quantity is. Well, check this bad boy out. It looks like the independent quantity is the number of minutes that we're hiking. The independent quantity is time, isn't it? It's the number of minutes that we have hiked. Which means the dependent quantity, if you recall, that's our y-axis, also going to be our h, however you want to think of it. And you can see that that's the number of feet in elevation that they're hiking down the mountain. So the dependent quantity is the elevation in feet. Yay. We've done some beautiful work so far, which is going to make some of these next questions super easy. I would like you to take a moment to answer all of the questions on number 3. Now, I can only kind of fit 2 at a time on my page, but of course you can see all 4 of these on your book. So number 3, I want you to analyze this function. We wrote out the function. We also have a graph of it. And I would like you to find, for part A, find the slope. For part B, find the y-intercept. Can probably do those really quickly. For part C, find the x-intercept. You may have to work a little harder for that one, but it's not impossible. And for D, you're going to want to give me the domain of the function. That one's been a while since we've done it. It's a little trickier, so I get if that one gives you a little trouble, but don't worry, I'll help you. So go ahead and hit pause. Give me the slope, y-intercept, x-intercept, and try to make a guess at the domain. And then go ahead and hit play when you're ready to check your work. All right, we've got this. Slope, that's the easy one, right? Slope is the guy next to the M. My slope is -20. I can see it, it's right there. Yay. Ooh, we are supposed to explain what it means though in terms of the problem situation. So this means that we're decreasing by 20 feet every minute, right? It's a rate of change. Every minute we've gone down 20 feet. That's why it's a -20. Our y-intercept is, of course, the guy hanging off the end. That's our 4,800. You know what this means. This is where they started, right? That y-intercept of 4,800, the troops started their hike at an elevation of 4,800 feet. So that's why that's our y-intercept. This one was a little trickier, but not impossible. The x-intercept, you could have set it equal to 0 and solved it, but there was another way, and that is use the graph. So I looked at the graph and I was like, oh, look, this is where it hits my x-axis. So this must be my x-intercept. So it looks like my x-intercept is 240. And what does that mean? Well, that's in minutes, right? And that's when we hit an elevation of 0. So that means that the hikers reached the bottom of the mountain in 240 minutes. Took them 240 minutes to get to the bottom of the mountain, or 4 hours, whichever way you want to think of it, that's fine. And for the domain, well, domain is x, right? Domain is what are all my possibilities for x for this entire thing. So it looks like for my domain, I started at 0 minutes, and they hiked all the way up until they got to 240 minutes. So the domain is 0 to 240, and we write it like this. We write it as 0 is less than or equal to x, less than or equal to 240. There are other ways of writing it, but this is a way of writing it. And it's just because they began their descent at 0 minutes and they finished at 240 minutes. So this is how we say that our domain, notice how x is in the middle, and it goes from 0 to 240, and we use inequalities to help us write that. So this might have been the tricky one. I think you guys are probably I know you did well with A and B. I think most of you probably also figured out C. D was the sneaky one, but not impossible, not impossible. So now let's go ahead and use the graph. We're going to use the graph to determine how many minutes passed if the troop is below 3,200 feet. Okay, so you're going to want to draw an oval on your graph as well to represent this part of the function and to write that corresponding inequality statement. So remember how we did this last time, how we could use the graph to help us find what we were looking for. You may want to go back, flip over to your notes from last time, see if you've got a few little reminders on how you can use the graph on this. Go ahead and hit pause, see if you can figure out how many minutes passed if we're below 3,200 feet, and then hit play when you're ready to check your work. So 3,200 feet, that's between 3,000 and 3,500, right? So I drew a horizontal line right there. And then I was like, oh, look, it hits right about there. Now, my graph is not perfect. It's not perfect. But this is where it happens. And I went ahead and they said to draw an oval on the graph to represent that part of the function. So if we want below 3,200 feet, this is the part of our function that represents that. So I just circled that with a lovely little oval. Guess I didn't circle it. I ovaled it. Something like that. And so it looks from the graph like, I mean, if that's 60 minutes, that's 120, that'd be 90. Again, I'm kind of estimating from the graph. This isn't perfect, but it looks like from the graph, if I were to drop a line straight down here, that about 80 or more minutes have passed if the troop is below 3,200 feet. So this point right here kind of corresponds. That looks like about 80. Again, we're kind of estimating here. So I would say that M is greater than 80 minutes. So we get to 80 minutes, and once we're past 80 minutes, we're below 3,200 feet. Okay. Number 5, write and solve an inequality to verify the solution set you interpreted from the graph. So we looked at the graph and we estimated that it was about 80, but we don't want to estimate. I want to know. So instead of using the graph, remember how else we did it last time? Remember last time how we set up an inequality and we solved it? Do that. Go ahead and hit pause to write and solve your inequality, and then hit play when you're ready to check your work. Okay, so I want to know when my function is going to be, and I'm gonna write this out. I want to know when my function h of m is going to be below 3,200, right? And we used a graph to figure it out, but now let's actually work it out. We know what h of m is. It's this guy over here. So let's do it. Negative 20m plus 4,800. And below means less than, right? It's below it. It's less than that. So it's going to be less than 3,200. And now let's do the math, right? We got this. I'm going to bust out some different colors. You know these tricks. I'm going to get rid of my plus 4,800 by subtracting 4,800. And you know how this goes. If you do it to one side, you must do it to the other. So those cancel out. That's why we did it. Let's be honest. I've got my calculator handy to help me out. I still have a negative 20m over here, and it's still less than, let's see, 3,200 minus 4,800 gives me a negative 1,600. Great. Next step. Now watch out for this one. I need to get the m alone, and it's being multiplied by negative 20. So I'm going to divide by negative 20 on both sides. Now, this is the trick. We divided both sides by a negative. Do you remember what happens to your inequality when you divide both sides by a negative? That's right. This bad boy here has got a flip. So instead of less than, it just became greater than. Don't forget that when you divide both sides by a negative, you flip the inequality. It flips on you. Watch out for that. Always important to notice these things. So those cancel out, and I just have an m. Negative divided by negative is a positive, and if I do negative 1,600 divided by a negative 20 on my lovely calculator, I get, I got 80. Hey, that's what we thought it was from our graph. So we did a pretty good job. Of guessing from our graph. It turns out we did all right for ourselves, so that's good. I'm going to go ahead and erase this so I can show you the prettified version of my work. The typed up. Isn't it so nice and pretty? All right. Can you take a minute and compare the two different ways that you got your solutions? They say compare and contrast the solution sets you wrote using the graph and the function. This just means compare our two strategies. Compare when we solved it with the graph, and compare when we solved it when we actually wrote out the inequality function and we solved it. What do you notice? Go ahead and hit pause, jot it down, and hit play when you're ready to continue the discussion. So I don't know about you guys, but I noticed that both ways gave us the same answer. Both strategies gave us the same solution set. We got the same answer whether we used the graph or whether we actually wrote an inequality and solved it. We get the same thing either way. So that is terribly convenient and good to notice. So let's talk about this relationship between our inequality statements, between h of m and m, okay? So we have these lovely guys here. Now, we already did this one. So you're going to complete the table by writing the corresponding inequality statement that represents the number of minutes for each height. Now, we already did this one. We set it up, we solved it, and we already found that m had to be greater than 80. So we already did that, all right? We already did this one. Here's what I would like you to do now. Oh, and I already see some typos in my work. That's terrible. Here's what I would like you to do. Go ahead and hit pause, given what you see here, given what happened here, and notice the numbers haven't changed. Given what you see happened here, what do you think the inequalities would be for m for these other guys? So we had h of m is less than 3,200, but when we solved it, we discovered that m had to be greater than 80. So what do you think m would have to be for these other guys? Go ahead and hit pause and write it down, and then hit play when you're ready to check your work. All right, so since h of m never changed and 3,200 never changed, I'm feeling like the m is always going to be there, and the 80 is always going to be there. It's never going to change. Whoa, I can't even write 80. That's very sad. That's a 0. Let me get the eraser. It's just not pretty enough for me. I want it to be pretty. So I'll put an 80 right there. There we go. That's prettier. Now, I notice that my sign flipped. So if this is h of m is greater than 3,200, then that means m is going to be less than 80. Oopsie. If h of m is greater than or equal to 3,200, that means m would be less than or equal to 80. This one, h of m equals 3,200, so m equals 80. Okay, fair enough. That one doesn't really do much. We already did this one. This was what we did earlier in the earlier problem. And so here's our last one. H of m is less than or equal to 3,200. So that means m must be greater than or equal to 80. Now, of course, we could have done the math to work all these out, but that feels like time I don't want to spend. So now that we have all of these, and we do, they're beautiful, they're lovely, you did a great job. Just take a quick comparison. Compare each row to the table. What do you notice about the inequality signs? I think I kind of already gave it away, but what do you notice about the inequality signs? Write it down. Hit pause, write it down, hit play when you're ready to keep the discussion going. Well, I hope you noticed that the inequalities were all reversed. They all got flipped. The inequalities in each row got flipped. So here's the big question. Now that we've noticed this, that our inequalities kept getting flipped, why? Why? Explain why that happened. So explain our answer from part B, that we noticed the inequalities were all reversed. So use what you know about solving inequalities when you have to multiply or divide by a negative number to explain why were all of our inequalities reversed. Go ahead and hit pause, write it down, and then hit play when you're ready to check your work. So yeah, I don't know about you guys, but I noticed that my original function was negative 20m plus 4,800. It had a negative coefficient for x. It had a negative slope, right? Negative 20. And so when I divided both sides by that negative coefficient to solve the inequality, when I divided both sides by negative 20, the sign reversed. So that's why it happened, because I was having to divide out that negative 20, that negative coefficient for x, and it reversed all my signs. That's how it goes. So let's move on to activity 3.4. So the inequalities that we've solved in this lesson so far have all been two-step inequalities, right? You only had to do 2 steps to solve it. It was just like, let's do this, let's do that, boom, solved, done. But of course, you know that just as equations can have more than 2 steps, inequalities can as well. So let's take a look at some more inequalities that are in some slightly different forms. So Allison and John each solved the inequality 5x plus 2 is greater than or equal to 3x minus 10. And what I'd like you to do for number 1, I would like you to describe the process that each student used to solve their inequality. So they both solved the same inequality. I would like you to describe, for part A, describe Allison's process, and for part B, describe John's process. What did John do? You're just telling me what they did step by step. Go ahead, and I'll come over here to 1A. Go ahead and hit pause to do both 1A and 1B, and then hit play when you're ready to check your work. So I'm going to start off with Allison. It looks like Allison had 5x plus 2, 3x minus 10. So it looks like she started off by subtracting out that 3x so that she could gather all of her variables to the left side so that these guys would cancel out. So first, the expressions containing the variables were moved to the left side of the inequality. She moved everybody over there. And so 5x minus 3x is 2x. Yay, and those canceled out. It looks like she then took charge of this guy, that plus 2, and she subtracted 2 from both sides so that those would cancel out. So the next thing she did was she gathered her constants on the right side of the inequality. So all of the constants, no variables, went over to the right side of the inequality. Fair enough. And of course, last but not least, she divided both sides by 2 so that those guys would cancel out so that he would go away. Beautiful. So the variable was isolated by dividing by 2. All right. Let's talk about what John did. So John also went for x's because he had x's on both sides. The only thing is John chose to get rid of the 5x. Do you see that? Minus 5x, so that those would cancel out. 3x minus 5x is a negative 2x. So John also gathered together his variables. But the first thing John did is he took the expressions containing variables and he moved them to the right side of the inequality. Allison moved them to the left, but John moved them to the right. And that's okay. That's okay. We've said there are a lot of different ways of solving these. It looks like the next step that John did was to get rid of that negative 10. So he added 10 to both sides so that those would cancel out and just leave them with 2x. And 2 plus 10 is 12. So he actually gathered then his constants on the left side. Again, opposite of what Allison did. Allison gathered her constants on the right, but John's next step was to gather the constants on the left side of the inequality. And of course, to finish it off, he got rid of that negative 2. So divide by negative 2, divide by negative 2, which means he had to reverse the inequality. So finally, the variable was isolated by dividing by negative 2, which reversed the sign of the inequality. All right. So we went from being greater than or equal to being less than or equal to. So what this means, here, I'm going to come back here just so we can see it. So take a look at their final answers. They use different methods. So number 2 is asking, first of all, how does the process of solving an inequality with variables on both sides compare with the process of solving an equation with variables on both sides? Go ahead and hit pause. Write down your thoughts. Hit play to keep the discussion going. So I hope you noticed whether it was an equation or an inequality, it doesn't matter. The process is the same. It doesn't matter. If you've got variables on both sides, you have to move them to one side or the other. Same as on an inequality, just like you do on an equation. It's pretty much the same thing. For both of them, you've got to move variables to one side and your constants on the other side in order to isolate your variable. The only thing I will say is that when you're doing an inequality, you have to pay attention to the inequality symbol. If you multiply or divide by a negative value, that inequality symbol gets reversed. So please, please, please watch out for that. The process is the same, whether it's an equation or an inequality. You've just got to keep an extra eye out for that whole multiplying or dividing by a negative, because it will reverse your inequality sign. So please be careful. Now, with that in mind, now that we've played with this a little bit, I would like you to do the same thing again, only I'd like you to do it with Karan and Ajani. I would like you to once again analyze their process, describe the process for each student used to solve the inequality. So what did Karan do? You'll do that for A. And what did Ajani do? You'll do that for part B. Go ahead and hit pause, write down their processes, and then hit play when you're ready to check your work. So it looks like the first thing Karan did is distributive property. Do you see it? It looks like he distributed property first to get rid of the parentheses, which is fair. That's fair. I get it. I'm cool with that. So that gives us a negative 4x plus 24. It looks like he then got rid of the 24 by subtracting 24 on both sides. So it looks like the constants were moved. So those would cancel. So he moved the constants to the right side of the inequality. So 22 minus 24 is a negative 2. And then, of course, the last thing he did was it looks like he divided by a negative. Dividing by a negative means you got to switch that inequality. You got to reverse that inequality. So finally, you've isolated the variable by dividing by negative 4, which reversed our inequality symbol. So well done, Karan. Well done. Next, how'd you do with the Ajani? So Ajani used a different technique. He didn't distribute. Look at what he did. He started dividing by negative 4. Karan and I divided by negative 4 last, but Ajani started with that, which means right away, Ajani had to reverse his inequality symbol. So first things first, both sides of the inequality were divided by a negative 4, which reversed the inequality symbol. And while that did give us a weird answer over here, maybe you would have put a decimal, negative 5.5, but Ajani went ahead and put negative 5.5. But look how much simpler this all of a sudden looks. Kind of nice. So from here, Ajani can isolate the variable simply by adding 6 on both sides. So yeah, next the constants were moved to the right side of the inequality thereby isolating the variable. So it looks like Ajani did have some slightly fewer steps, but he did end up with some slightly weirder numbers in the middle. So again, how does the process of solving an inequality using the distributive property compare to the process of solving an equation using the distributive property? Is there a difference? What is the difference? Go ahead and hit pause, jot down your thoughts, and then hit play when you're ready to keep the discussion going. Guys, you know what I'm about to tell you, right? There's no difference. The process of using the distributive property to remove parentheses is the same. Whether you're doing an inequality or an equation, it doesn't matter. Distributive property is distributive property. I don't care if there's an equal sign in the middle or a less than sign. It doesn't matter. It all does the same junk. All right, let's go to our talk the talk over on page 132. We're just going to do number 1. I'm not going to have you guys do number 2 on this page. We're just going to focus on number 1. And basically, it's kind of a throwback to what we were doing last class. I just want to make sure that we're there and that we're up on it. So what I'd like you to do for A, B, C, and D, for all 4 of these, solve the inequalities, all right? So start off by solving the inequalities and then graph the solution. You may need to flip back to our pages from yesterday, to our activities from last class. I shouldn't say yesterday, but our activities from last class to remind yourself how we graphed our solutions. Go ahead and hit pause, work these out, and then hit play when you're ready to check your work. Okay, so I needed to get the x alone, and I'm being multiplied by a negative 2/3. Some of you guys think of it as dividing by a negative 2/3, which you could do, but the easier way to get rid of a fraction is to multiply by its reciprocal. So I'm going to take this negative 2/3. The reciprocal is negative 3/2. So I'm going to multiply both sides by negative 3/2. Ooh, and I'm multiplying by a negative, which means I have to reverse my inequality. So instead of greater than or equal to, it just became less than or equal to. And of course, the nice thing is negative times a negative gives us a positive. The 3's cancel out, the 2's cancel out, and we just have an x. We do maybe need to do a little work here. So if you're trying to remember how to do this, first of all, positive times a negative is a negative. And remember how we multiply with the top and divide out the bottom. So 7 times 3 is 21 over 2. If you wanted to, you could write it as a decimal, which I believe would be negative 10.5. So that means that x is less than or equal to negative 10.5. All right, so let's put this on a graph. First of all, I need to figure out where negative 10.5 is. So I put down negative 11 and negative 10, and I'm like, okay, well, negative 10.5 is in between those. So I didn't totally label my number line. I should have labeled my number line more, but I was lazy and I didn't. So I have negative 10 and negative 10, negative 11. Since they are negative, they go in that direction. Negative 10.5 is in between. Now, open circle or closed circle. I have a squashed equal sign. That means that negative 10.5 is part of the solution set, which means it's a closed circle. Also, I noticed that x is less than 10.5. X is the smaller guy, so I've got to go in the smaller direction. Remember, left moves us in the smaller direction, so I've got my big arrow pointing, well, to the left. Okay. What about part B? How'd you do on part B? Well, I needed to get the x alone. Please remember that this is a positive 23. We've talked about this before. So if that's a positive 23, I need to subtract 23 from both sides in order to get the variable alone. So that will cancel out. Hooray, hooray for us. And 32 minus 23 gives me 9. Now, I still have a little issue here because that says negative x, and I don't want a negative x, I want a positive x. So we've done this trick before as well many times. So let's go ahead and multiply both sides by a negative 1. But because I'm multiplying both sides by a negative, I have to reverse my inequality. So my greater than symbol just became a less than symbol. And of course, negative 1 times 9 is 9, and negative x times negative 1 is a positive x. That's why we did it. I don't like writing it this way. If you want to leave it this way, that's totally cool. But some people like having the x on the left side. That's fine. Just keep in mind, alligator eats the bigger one, and clearly x is the bigger one. So if I flip this, I have to fully flip it. I got to flip that inequality to go with it. So instead of negative 9 being less than x, you can rewrite this as x is greater than negative 9 because the alligator eats the bigger one. So I just need to make sure that my alligator is eating x, whichever way I put it. Time to graph. So negative 9. And so just for context, I put a negative 8. I put a negative 10 on there, right? It's in between them. And open or close circle. Well, I don't see a squished equal sign. X cannot equal negative 9. It's not part of my solution set. So I put an open circle on my negative 9. Sorry if it's a little bit off. I had some issues there. So I put an open circle on my negative 9. This says that X is the bigger guy, right? Alligator eats the bigger one. So if I'm going bigger, I'm going to the right. So my arrow goes off forever and ever to the right. For part C, the first thing I noticed on C is that I needed to do some distribution. So I did distributive property, 2x plus 12, then is what I get, 2 times x, 2 times 6. I was like, oh, let's get rid of the plus 12. So I subtracted 12 on both sides. You can see I subtracted 12 on both sides so that these would cancel out. And of course, 10 minus 12 is a negative 2. Last but not least, I need to get the variable alone by dividing both sides by 2. Now notice, my inequality does not flip because I'm dividing by a positive 2. It doesn't matter if this guy on top is negative. I don't care. He can be whatever he wants. The point is that the stuff on the bottom that I'm dividing is positive, so I don't flip the inequality. And of course, it means these guys cancel out, which is why we did it. And negative 2 divided by 2 is a negative 1. So again, I'm going to put it on my number line. So negative 2, negative 1, 0, just to kind of get some context there. Open or close circle. Well, I don't see a squashed equal sign, so x does not equal negative 1. It's not, negative 1 is not part of the solution set. So open circle it shall be. I see that x is less than that, so x is smaller, so that means I gotta go left. The smaller side is to the left side. Last but not least, part D. Part D. Now again, more than one way of solving this. I've got x's on both sides, but I really don't like that negative 4x. It's kind of freaking me out. So I went ahead and I added 4x to both sides, just for me. That's how I like to do it. You may have used a different method. That's okay. We already discovered earlier that you can use different methods and get the same answer. So those cancel out, and so I have 15 is less than or equal to 3x plus 4x, which is 7x minus 6. Next up, let's get rid of that minus 6. Of course, we will do that by adding 6 to both sides. Sorry, my colors went a little off. So we will add 6 to both sides, which of course cancels these out. That's why we did it. And 15 plus 6 gives me 21. Last but not least, in order to get the x alone, I will divide both sides by 7. And since it's positive, I don't have to flip the inequality, so that's good. And of course, these cancel out. It's why we did it. And fortunately, this is a nice one. 21 divided by 7 is 3. Now, again, a lot of people don't like it written this way. A lot of people like having their x on the left side. They don't like having their x on the right. They want it on the left, and that's fine. That's fine. So that just means I need to flip everything. So it's literally, I'm going to take the whole thing and just like reverse it and flip it. So x is the bigger guy. So I'm going to put my x over here, make sure my alligator is still eating my x, just like it said it was earlier. And my 3 is over there. So I just fully like flipped everything around. All right, let's graph it. So that's a 3. So make sure I can see 3 on my number line. So I just 2, 3, 4. Open or close circle? Well, I see that it's greater than or equal to. There's a little squashed equal sign. So 3 is part of my solution set this time, which means it will be a closed circle. X is greater than or equal to negative 3, so it's bigger than 3. Bigger than is to the right, people. And there you go. All right, guys, as always, I hope you found this helpful and I hope you found this useful. If you have questions or concerns, please, please, please email me or talk to me. Talk to me during class. Stick around after class. Come see me during office hours. You know I'm here to help you out. In the meantime, I'll see you guys later. Bye.